Okay, these are the notes for 9-4 exponents and quotients. We've already gone over the exponent rules for multiplying and the power to a power. So now we're going to look at division. So we're going to do the same thing where we look at expanded form first. So I have 3x's across the top. Below it I have x squared. And when you divide something, anything divided by itself is 1. So when I divide these, I'm left with a 1. When I divide these, I'm left with a 1. So my product is 1 times x, which is just x, or x to the 1. Okay, we're going to repeat the same idea down here. We're going to shrink this up a little bit. So I have 3x's. Top. I have another x below, and then I'm going to cancel, and that leaves me with x squared. And the last time, I'm going to have 5x's across the top. And I'll have 2x's on the bottom. And then again, I'll cancel. And I'm left with x to the third power. I have 3x's left over. So look at the relationship. I started with a 3 and a 2. I ended with a 1. I ended with a 3 and a 1. I ended with a 2. I ended with a 5 and a 2. I ended with a 3. So hopefully you've seen the relationship between the exponents you started with and ended with. So your rule is going to be x to the a minus b. So that's your rule for division. If they have the same base, which is the number you're raising to the power, you're going to subtract the exponents. Over here, we're just going to do that one more time. I have x over y squared, so x over y times x over y. And that gives me, because when you multiply fractions, you multiply across the top and across the bottom. So I get x squared over y squared. If we do the same thing here, I have x over y times x over y times x over y again. Okay, and that's going to give me x cubed over y cubed. And the last one, x over y to the fourth, so I have x over y 4 times. Let's see if I can do this. Ha-ha. 2, 3, 4. And so what that gives me at the end is x to the fourth over y to the fourth. So your rule is going to be, hopefully you saw, this is kind of like when we did the quantity x over times y to the a power. We did that yesterday, or in 9-3. So these are all to the a. That should be an a. I know it looks kind of like a 9. That's an a. So this is your next rule. And what we're going to do next are some examples. So I'm going to ask you either copy these down or work through these examples in your notes if you printed them out, and then push play again when you're ready for to check your answers. Okay, for the answers, as I went through here, I was dividing. So this, you kind of visualize. I have 10 x's across the top, 4 x's across the bottom. When I cancel, okay, I'm going to have 6 x's left across the top, or x to the 6th. 10 minus 4 is x to the 6th. Over here I have a over b 7 times in a row. So across the top I have a to the 7th, and across the bottom I have b to the 7th. When I come down to this, 15 and 5 are not exponents, you're dividing. So 15 divided by 5 is where I got the 3. Then I went with the x's. X to the 6th over x squared. Again, 6 x's in a row, 2 x's, so you'd cancel. You'd be left with 4 x's. Or 6 minus 2 is x to the 4th. And for the y's, I'll subtract their exponents. 7 minus 4 is 3. In this example, again, 56 divided by 8. Coefficients and exponents are different and mean different things. So I have 56 and I divide that by 8. That's where the 7 came from. X to the 4th over x to the 4th. Well, if I had 4 x's across the top and 4 x's across the bottom, all of them would cancel out. So I don't have any more x's. And I just have 1. And then I have y to the 6th. I just have the number 1. Anything divided by itself is 1. We're going to get more into that rule later. So 7y to the 6th is my final answer. Over here, the first thing I did was I did this piece. So I have y to the 5th over x to the 5th right here. And then, remember, multiplication is commutative. You can flip these two around, the two numerators. It's still the same thing. So I did x to the 9th over x to the 5th. 9 minus 5 gives me x to the 4th. Y to the 5th over y cubed. 5 minus 3 is y squared. And the last one here was cannot be simplified. This is a bunch of x's. This is a bunch of y's. Nothing's going to cancel. That's as far as I can go. All right, on the next slide, again, if you have the printout, you can work through these. If you don't, you're going to push pause, copy them down, and work through them yourself and come back to check your answers. Okay, in the first one, the x to the 5th over 4, I left that there. Then, remember, this is 2 over x, 3 times in a row. So that means there's 2 times 2 times 2. That's where I got the 8. That's 2 to the 3rd power. And I also have x cubed on the bottom. Again, 8. You could flip these around if you wanted to. 8 divided by 4, that's where I got the 2. X to the 5th over x cubed. I'm subtracting the exponents. That's where the x squared came from. Over here, I'm kind of doing power to a power rule that we did in 9.3 and a rule we did today. So I'm going to have 2 times 5. That's where x to the 10th came from. Because remember, this would be x to the 5th times x to the 5th. That's what squaring means. I would take these two and multiply them together. So that would give me 10 x's across the top. I have y to the 4th times y to the 4th, which is y to the 8th, or you could also do 4 times 2 is y to the 8th. So there's your answer for that one. In this one, I have x times y 5 times in a row. So I have x to the 5th and y to the 5th. And then the x cubed I just brought over. Then I have x to the 5th over x cubed. 5 minus 3 gives me the x squared. And I just brought the y to the 5th along. In the next one, I'm going to recommend this with numbers. You guys tend to really, anytime it's a number raised to a power, you desperately want to figure out what it is, especially if it's the same base. This is a 2. This is 2 to the 5th and x to the 5th. Because these are the same base, I'm not going to multiply this out. Now, I understand that that number may not be too hard for you to multiply out, but what if it was 2 to the 10th? Remember, this is like 2 to the 1. So, same base, I can just subtract their exponents. 5 minus 1 is 2 to the 4th. X to the 5th over x to the 5th, they all cancel out. Everything's gone there. So, 2 to the 4th, which is 16. Your final answer is 16. The last one, again, I'm multiplying. 4 times 2 is what gave me the 8. 4 times 3, that's what gave me the 12. X to the 5th, y to the 6th, just brought over. Now I'm going to look at the division. 8 minus 5 is where I got the 3. 12 minus 6 is where I got the y to the 6th. On the last one, again, I'm making that 6th go to each of the different factors. So I have 5 to the 6th, 8a to the 6th, b to the 12th. 6 times 2 is 12. On the bottom, I have 5 to the 3rd. I have a to the 6th. 2 times 3 is 6. b to the 3rd. Notice again, I did not multiply these out with the 5s. They both have 5, so it's easier for me to handle the exponents than it is for me to do that long division. So same base, I'm going to subtract the exponents. 6 minus 3 is 3. A to the 6th over a to the 6th. Well, all those a's are going to cancel out, so that's just a 1. Cancels to be 1. 12 minus 3 is b to the 9th. And then my last step, well, 5 to the third is much easier to figure out than 5 to the sixth and then 5 to the third and dividing it. So 5 to the third means 5 times 5 times 5, which is 125, and then the b to the ninth. And that concludes our notes for 9-4.